All right. So for systems of equations, the first possibility is you have one solution or one point of intersection, and we call that point the break-even point. When there is one solution, we call it consistent and independent. It's independent because they only intersect in one point. The second possibility is that the two lines never intersect. And what type of lines won't ever intersect?
Parallel.
Parallel, right. So we're talking about parallel lines here. Parallel lines will never intersect, so there will not be a solution. And when there's not a solution, we call it inconsistent, and they're independent. The final possibility is you have two lines, and one ends up being a multiple of the other, and you go to graph it, and you realize, hey, it's on the same line. If that happens, that means that every point is going to be a solution to this because it's the same line. And when that happens, they call it consistent and dependent because the one depends on the other. We are going to use that to solve these by graphing. Now, the first thing you want to do when you're doing this is you want to get it in slope-intercept form and look at the slopes. Because if you have the same slope and the same y-intercept, that tells you it's the same line. However, if you have the same slope and a different y-intercept, what does that tell you about the two lines? They're parallel, right? So a lot of times, if that happens, you can just look at your equation and say, hey, these lines are parallel. They have the same slope but different y-intercepts. That means that they're going to be inconsistent and independent. There's not going to be a solution for them. So again, it's first important to get your lines in slope-intercept form and just take a look at the slope quickly. All right, if we look at number one, are they parallel? No, it's already in slope-intercept form and they have different slopes. So we don't have to worry about that. So let's go ahead and graph them. I want you guys to graph this with me. And it's helpful to number your lines. If you have more than one, just number them. If it helps you, you can identify your slope. You can tell what direction. Which direction is the first line going to go? What was it? Decreasing, right? So if that helps you, just draw it, just write it so you remember. The second line, it's positive, so it is increasing. Or slope for the second one is 1/6. Y-intercept is 5 and -6. So if we graph the first line, let's do that one in red. We began at -6, so I want you guys to put a point on the y-axis at -6. Then we are going to rise 5 and run 3. But make sure that it's decreasing. Rise 5, run 3. Oops. And so here's our first line. And I told you guys yesterday, when you're graphing more than one thing on a graph, you want to label them. So we can label this line 1 since I numbered them up here. Once you've graphed your first line, go ahead and graph the second line. Bless you. What's the y-intercept of the second line? 5. So let's go up to 5 on the y-axis. This one's increasing, so if we go up 1, we go right 6. Bless you. Or down 1 and left 6. 1, 2, 3, 4, 5, and oh. You guys see it? Did we find the solution? Yeah, what's that point of intersection? Yeah, -6, 4. So the solution And we put it in squiggly brackets because it's a solution of them, is negative 6, 4. There's also a way that you could just check and make sure that it is in fact a solution. How could we check to see if this point is in fact a solution of each of these equations? Any thoughts? Like if you were asked, is this point a solution of this line? What? Yeah, plug in the x and y. You can always check just to make sure. Plug the x value in, plug the y value in. And if the left side is equal to the right side, you know that it's true. We did it by graphing, so we know for sure that it did intersect at negative 6, 4. But you can always check to see if something's a solution by plugging it back in and see if it makes it true. So that one is done. Let's go on to number 2. What type of line is y equals 5? Horizontal, right? Again, when you notice one of your variables is missing, go to that axis. So we go to the y-axis, and we cut it right at 5. So I'm going to label this one 1, the second one 2. We're going to cut the y-axis right at 5. Now I want you guys to graph number 2 and see, be very careful when you do it, see if you can figure out what their point of intersection is. So you're graphing that second line to see if you can figure out where they intersect. You gotta write that down, that's your solution. All right, so some really good work. So let me remind you guys, when you write your point, you want to write your x value first. The x value is your left or your right. So if we graph this line, the second line, it begins at 7 on the y-axis. It's a positive slope, so we know it's going to increase, and it's going to go up 2, over 1 because our slope is 2 over 1, or down 2, and look, over 1, we found our point of intersection. Once you find your point of intersection, you want to write that point down because that's the solution. Remember to go to that point, start at the origin, go left or right first. We have to go left 1, so it's a -1. Then we go up 1, 2, 3, 4, 5. So our solution to these two lines is -1 and 5. For questions like number 3 and part of 4, you have to turn it into slope-intercept first. So if we look at the first line, actually let's do the second line first because it's got space under it. How do I turn the second line into slope-intercept? Thank you. Subtract the 2x from both sides. We get 2y equals -4 minus 2x. Again, be very careful when you copy down your signs. And final step to getting y by itself, divide. I'm still seeing a couple of people do this and stop. What's the problem with that? Yeah, it's not balanced right now because we haven't divided the -2 by 2. So you have to divide. When you divide or multiply, you have to do it to every single term. A term is separated by a minus, a plus, or an equal sign. So here we have 3 separate things. There's an equal sign and a minus sign, meaning there's 1, 2, 3 separate things that we have to divide by 2. So again, if you're one of those people not dividing everything, take note now and make sure that you correct that. So our equation for the first one, simplify it as much as possible. It's -2, and watch your signs, minus 1x or minus x. I'm going to put the 1 there just so I remember it's going to be up 1 over 1. That was the second equation. Now I'm going to take that first equation and do the first equation. What's the first thing that we do on this first one? Right, move the 6x. So to get it in slope-intercept form, you want to move the x away from the y. When I do that, I get -5y equals -45 minus 6x. Now what do we do? Divide, right? Divide everything, not just the -45 and the -5, but divide everything. And always be careful about your signs. What happens to these two negatives? Positive. +9, and again, 2 negatives turn into a positive. 6 over 5 can't be reduced. All right, I want you guys to graph lines 1 and 2. Let me label that one 2, or 1. So graph your lines and see if you can figure out where they intersect. And if you finish before I come around, you could start working on that homework on the front page. We can't do the back page yet, but we can do the front page. Does anyone need extra help during this time? Struggling with graphing or? This one is a positive slope. So when you start up here, you're going to be increasing. So instead of going that way, it's going to go down 6 and then over 5. Okay. So they should intersect to change that. Oh, that's it.
I still can't get over how ugly this is.
I would have more issue with the polo.
So like these eventually will match, but not on the ground. So these guys is like
Alright, so you guys got on this one, or you should have gotten, for this one, your solution should have been -5, 3.
Yeah, I did it, but I did it like backwards. Like I did it the other way, but I think I read it.
Alright, for the next one, we know the slope of the second line is -1/2, but how do we find the slope of the first line? How do we find the slope of the first one? Yeah, subtract the 3x. So if we subtract the 3x, I'm going to rewrite it down here and do it. Okay, what's the next step? Divide, good. Again, guys, we have to divide everything to keep our equation in balance. And we get y equals -2 minus, what's 3/6 reduced to? Right. Okay, what do we notice about them? The what? Same slope, right. Do they have different y-intercepts? Yeah, that means if they have different y-intercepts, that means they're going to run straightwards and parallel, right? And parallel lines have what type of solution? No solution. So this one, just by turning them both into slope-intercept form, we already know that they're parallel and no solution. So I'm not going to even make you guys graph that one because we already know that if we graph them, they're not going to intersect. So we're going to leave it just like that. All right, for number 5, 2y equals 8x plus 18. What do we have to do on this one?
Get it in the form.
Yeah, get it in the form. And this one, the x is already moved over, so what do we have to do to this y? Divide by 2, right? So that one's not too hard. We divide by 2, we get y equals 4x plus 9 for the first one. Let's go ahead and do the second one. This one's written kind of strange, but let's see if we can make it look like slope-intercept. Usually we have to move the x away from the y, but this time we have to move that 24 away from the y. So we move the 24 on the other side by subtracting it. We get 4y equals x minus 24. What do we do in the last step of this one? Last step to get y by itself? Divide, right? We divide. Oh, that gives us our slope of 1 over 4. We get y equals 1 over 4x minus 6. And look at the slopes, guys. 1 is 4. Oh, that's not negative, so okay, never mind. I was going to say they look like they're going to be perpendicular, but this is not negative. To be perpendicular, they'd have to be the opposite sign as well as the reciprocal. So they're not even perpendicular. Go ahead and graph this with me. So we're going to graph 4x plus 9. This is good practice. So again, graph it on your paper and check and make sure it looks like mine. All right, go ahead again, graph it, see if you get the same solution. So this is a good check for you to make sure that you're graphing like you're supposed to be.
Sure, I don't know. I just keep messing it up and I'm just doing that. That one just made me mad because I thought I did it right. What, I just can't remember.
Yeah, it says bring me with, please. Huh? Bring me with. Is it 1010?
Yeah.
Wait, actually?
Yes, but remember which you're supposed to be positive?
It's not 1010. Oh, it's 10. Yeah.
Your slope is negative.
Wait. Well, that's weird.
Okay, you said it's that.
It's 1010.
I feel like that's more positive.
Oh, okay.
I add falling from left to right, negative and rising from left to right. This one rises from left to right. Falls from left to right. So you did yourself right. You just have to do the other way. To make it rise. Is there another way of making it rise?
I'm happy. I'm okay with that. The last day of the week,
We get to sit in the gym for an hour and a half and watch everybody shut up at the lunch table.
I'm gonna sit.
Oh, is that where they're at?
Yeah. I'm gonna sit.
That's what we're trying to have in chapel is watching videos.
I did that last night.
So that
Yeah, I thought when it's flipped up to girls travel, I forgot. They had like
Oh, like the other week?
remember it's like all boys and like
Yeah.
so like
It's positive, you will know.
It's 20 minutes.
yeah, we went to like all classes.
down one, the right one. That's fine.
Our speaker was not good. Apparently there's.
Oh, the speakers.
They usually get good ones from like
They would
those.
intersect with that.
And if you can see it,
Yeah, they get the conversations. Those are fun.
they tell you like food and drinks and like a Broadway.
We are,
I know.
we are locked in the gym
Start here.
watching a guy put us to sleep. That is how we're chatting.
It's so boring.
That is how guys chat.
But it just looks like your slope's backwards. It's the only thing you're doing your y-intercept right, you're doing your like you're moving the driver the wrong way. So that's the only thing. Right.
It's so fun.
Negative one. That would be
It's even
class.
worse than shopping.
All right, guys, let's do our last question, and then we're done for the day. Is number 6 is the first equation in slope-intercept? No, what's wrong? Why is it not? Right, the negative 1. So get rid of everything in front of the y. If there's a negative, just divide everything by negative 1. And what that does is it literally just changes the sign of everything. So I'm going to rewrite equation 1. It's y equals x plus 6. So instead of being negative x minus 6, it makes them positive. For the second equation, how do we get y by itself? Right, divide everything by 3. Now this is another one we're not going to have to graph. 18 divided by 3 is what? 6. 3 divided by 3 is 1. What do you notice about these two equations? The same. And what does that tell us about the solution? Same line, and there's an infinite number of solutions. That's because they're the same line. Every point is a solution. All right, guys, for homework, I want you to do the front side of the packet, please.
Hello.